So in this video I'm going to cover how we would perform simple change detection, both a raw DoD and applying a minimum level of detection in a GCD project. Similar to how we did in the last exercises, but now you'll see that a lot of things are already taken care of for you. So I'm going to go ahead and I'll just save my map document to start out here. I always like to store relative path names to data sources. Hit apply, and then I'll click save as, and I'm going to go into my folder here, GCD California Sulphur Creek, and I'm going to name this Simple DoD Part 2. Go ahead and click save. So to start a GCD project, I'm going to go ahead and click new under the DoD toolbar, pull it down here, click new GCD project. I'm going to navigate to the folder that I want. So Simple DoD, California Sulphur Creek, that's where I want it. And I'm going to name it that same thing, Simple DoD Part 2. And I know that the DEM that I'm going to be added are at a 0.5 resolution, so I'm going to keep my horizontal precision at 1, meaning 1 decimal place. If you want, you can provide a description. I'm going to go ahead and leave that blank. But I'll hit OK. Now I have the bare bones of a GCD project here on the left. The first thing to do is I'm going to add my DEM. One way to do that is right click on this node here called DEM surveys and click add DEM from the menu that pops up. Then I'm going to click on this open folder button here. Because I don't have any DEM in the map, this isn't populated at all. And I'm going to navigate to the DEM that were in my folder here of my exercises folder, Simple DoD, California Sulphur Creek. And it doesn't matter what order you add it in, but I'm going to add the 2005 one first. Looks like whoever was managing these already had them clean and dimensionally divisible, so I'm not going to need to perform any of that. It's just going to copy it right into my project. I'm going to go ahead and keep the same name. Nice thing about that is it's going to add it with all the symbolization that we didn't have in the raster calculator, and it'll also add a nice hillshade so we can kind of pick out some of these details. So I'm going to repeat that process. Right click on DEM surveys, hit add DEM survey. And as I said, because there's rasters in the map, they'll be populated in this drop down, but I don't want to add the same raster twice. But I do want to add my 2006 DEM, so I'm going to go ahead and select that and click add. And again, whoever created these looks like they're doing a good job of respecting dimensional divisibility, and I can just go ahead and bring this right in. And because we're going to be performing simple change detection, I'm not going to add any associated surfaces or error surfaces. So I can just, if I want to, I can look at some of the properties of my raster here, my extent, cell size, the width and height, number of rows and columns. But everything looks good there, so I'm just going to go ahead and hit Save Survey and Close. We'll get into some of these other tabs and attributes in other exercises. But for now, we're just focused on performing what we did in the raster calculator, but letting GCD do it for us in a very straightforward way. So once I have my two DEMs added to the map, they're nicely symbolized, and I have my hillshades, I'm going to go down to the change detection node here, and I'll right click on that and I'll say add change detection. And what automatically pops up is a drop down that's populated with any of the DEMs that I have in the survey. And we have an area for new survey and an area for old survey. So because I do want erosion to be displayed as negative, I would definitely want to subtract my new survey minus my old survey. So I'll go ahead and switch that, 2006 minus 2005. You can see it's automatically changing this analysis name for me up here, which is nice, so I can keep track of it. And then down below here we have the uncertainty analysis method. So we have simple minimum level detection, propagated errors, and probabilistic thresholding. We'll get into these other two in other exercises, but for now we're focused on simple minimum level of detection. So rather than going through creating those masks and using the raster calculator, we just have this nice click button here that I'm going to lower that to 10 centimeters, which is what we had set in the previous raster calculator exercise. And you can see that when I do change this and then go to another area of the form, it updates here in the name, so it's easy for me to keep track of. But I'm going to go ahead and keep that at 10 centimeters. I'll check my inputs. If I did want to add something here, so I knew I could type something here, but I'm going to keep it as it is. And I'm satisfied with that, 2006 minus 2005, with a simple minimum level detection of 10 centimeters. So I'm going to go ahead and just click calculate. And what happens is we have the same thing as the raster calculator. It's added to the map, except with 10 centimeters thresholded out, except now we have that layer symbology automatically added. And then instantly the change detection results panel pops up. Won't get too much into this in this tutorial. In later tutorials we'll describe more what's going on here. But here we have the raw numbers of the volumetric change that's actually occurring. Well, here we have the areal change. This would be raw without the minimum level of detection applied, and then this is with the threshold. And then here we have volumetric, some vertical averages, and then just some general what percent of this is deposition and what is erosion. And then here we have a histogram of how you can look at this, with the red representing erosion, the blue representing deposition, and then this gray area is the change that was removed from the total amount that we are considering real change, because it was below that minimum level of detection. If you look closely here, you can see that this is 10 centimeters plus or minus around 0. So this is the areal, and then here we have the volumetric. And then here we also have some bar charts representing similar things, where we can change from volumetric to vertical averages. Again, we'll get into this in later exercises. But one thing that is nice about this form, if we did want to know where our inputs and outputs are from, they are right here. So we can explore this a little bit. But it's as simple as that. Here we've performed a thresholded change detection. Rather than going through all the trouble of creating logical masks in the raster calculator. And I'm going to go ahead and save my map document for that. And we'll cover more about change detection in other exercises.